day, viewers. This is Afia de Molar Johnson, your chemistry and biology tutor. So today we want to look at another area in number 1 question of NECO 2024. So you have watched the previous video of the first type of titration we did that revolve around the salt, the sodium carbonate you were asked to titrate with H2SO4. So today we want to look at another pattern. They can ask us a question like what you have on the board. You say A is a solution containing 3.35 grams of H2SO4 in 500 cm3 of solution. But take a look at this B. B is a solution of X2CO3 instead of Na2CO3. Now you have X2CO3 containing 5 grams per dm3 of the solution. Now they now say put A into the burette. You want to titrate now and titrate it against 20 or 25 cm3 portion of B using methyl orange as indicator. Repeat titration for 2 or 3 more times. Tabulate your burette readings and find average volume of A used. So given the equation of the reaction as follows. So the equation of the reaction is given like this. So now let's go on and titrate according to the instruction given to us. So to titrate, first thing is to look at the table. This is the table. You must indicate the size of the pipette, which is 25 cm3. You can see that written here, 25 ml on the pipette here. It will be written here, 25 ml in the pipette. You see there. That's 25 ml. See here, 25 ml written here. So in some other schools, their own will be 20 cm3, and that is why it is stated here that they say put it into the burette and titrate it against either 20 cm3 or 25, but the one we have there is 25, and that is what makes it important for you to put 25.00 cm3. If you don't put this thing here, this information here, the examiner may not even mark anything. He will be confused because there are 2 marking schemes. There is a marking scheme for the pipette of 20 cm3, and there is another marking scheme for the pipette of 25 cm3. So you will not know the marking scheme to use to mark the street. So it becomes very important to put 25.00, and it must be in 2 decimal places, and you must put cm3. So then in your table you have your final reading, you have your initial reading. Initial reading is, initial means at the beginning. So, and the instruction says put A into the burette. On that day of the exam, you will be given, you see 2 beakers. One will be labeled A like this, and the other one will be labeled B like this. Be labeled B. So now the instruction is now saying that you should put what? Put A. So you will locate the one, you put your funnel in your burette, and you will clip your burette. And after doing that, you now locate A. This is A, labeled A. They say put it inside your burette, which is what you are doing now. Now remove your funnel, then regulate the A to be adjusted to 0 cm3 here, the beginning of the calibration. So with your marker, with your pen, you put 0.00 here. That is your initial reading. Initial reading under rough reading. That's it. Because you have filled the burette to the brim, to almost the brim, 0.00. So it is at 0.00 here. That is initial. Initial means what are you starting with? Then the next thing, after putting, they say put A into the burette, which we have done now. The next thing is to titrate this A we have in the burette against 25 cm3 portion of B. How do we collect 25 cm3? We will use our pipette, whose size is 25 cm3, to take our B. Now we have it there. Then watch, there is a ring here. So to suck, I will use this to suck the bead. Then I will suck it above it properly. Then use my tongue to hold it. Then after holding it, then I use my hand to transfer my hand to hold it. Before I will now take it there. See what I want to do now. So I've transferred it now. So I will now be adjusting it until it goes to that ring. Okay. Then I'll take my conical flask. I will release it inside it. Then, after that, they say, we are following strictly the instruction here. They say, using methyl orange as indicator. So this is a methyl orange. Let's wash. See the color of the methyl orange. Methyl orange is yellow here. The color of methyl orange in an alkaline solution is what? Is yellow. So we have it there. So I'll take this one away. Then I can titrate. To titrate means to release my air, to be touching this. And I'll be shaking it. Yes. The color has changed. And to be sure, I can take it to a white tile. I can take it to a white tile to see that the color has already changed. The color has changed now. So then the next thing to do is to read my burette. My burette here now, this is 0, this is 1, 2, then 2, this is 2.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then 3. So it is on 3.00. So my rough reading now is my final reading 3.00. Then if I take away this 0 from here, I will have 3.00. Then I may need to fill this again, but if it is every 33 cm3 that is causing the change, I may not need to fill it again. And that means my initial reading now is still the same thing as well, the 3.00. So if that is it, I want to begin another titration. He said I should do it 2 or 3 more times. He said I should repeat titration for 2 or 3 more times. So now I want to do it the second time now. My B. So I take it here. Then exactly what I did before, I'm doing again. I should expect a color change around 8. Yes, something has happened here. So to be sure, I take it close to a white tile, and my second title now, from that information, I have 6.00. So taking this one away, I have 3.00. So I may still continue from 3.00. So you should expect that if you titrate again, just ensure that the difference between one titer and the next immediate titer is between the range of 0 and plus or minus 0.2. So if I add 0.2 to this number, what will I have? I will have 3.20. So what number will I put here? So if I add these two numbers together, I have 6.20. So that's how to manage your table. Then the next thing is to find average volume of A used. To do that, I don't need my row, I'll cancel it. So I only need my first reading and my second reading. So I have 3.00 plus 3.20 divided by 2. I'm using 2 because I don't have the third reading. I didn't mean I have the third reading. I will say, I will add them together and say divided by 3. So what do I have here? I have 6.20 over 2. And that gives me what? 3.10 cm cubed. So 2 decimal places, and ensure that you put your right SI unit. Now let's now begin to solve the problems one after the other. Then I'll say, from your results and the information provided, find the concentration. So number A now. We want to look for the concentration. Concentration of A in gram per dm cube. Concentration of A. Go to the question.